My name is Snow, and I'm an Android developer at Groupon, Silicon Valley, working on the amazing e-commerce app for millions of users. Here are the ways that you can reach out to me. Feel free to email me, or Twitter is probably the best way at Zhao Siruo. Also, G+ Zhao space Siruo is another good way. So, as I said, I'm here today to talk about the static code analysis tool Lint, specifically Android Lint. Of course, since we're here at droidcon SF. I will briefly touch on what is static code analysis, what is Lint, and go straight into the fun part, customizing Lint. I will show you how to suggest a builder pattern for a constructor with too many parameters using Lint, where I will explain the components for a Lint rule, the AST and UAST APIs that Lint is using, and of course, how to test our new rule. After that, I'll go over some common static code analysis tools in Android and provide guidelines on how to choose the best tool for a specific need. And at the end, everyone's favorite part, Q&A. So please save your questions to the end as we're trying to cover a lot of contents today. Now, let's take a deep breath with me. And off we start. Please do me a favor and raise your hand if you've seen this before or something similar. Great, thanks. If you've been developing Android for a while, this must look quite familiar. This is a snippet of a Lint report generated after each build. In this particular one, there are 4 warnings and 1 arrow in categories such as correctness, security, and usability, etc. If I want to look at more details on a particular issue, for example, the first one, duplicate IDs, I can just click on it, and then I'll be going to the corresponding session like this, where the exact location of the issue will be highlighted, and also you see the code snippets, and of course the ID, the category again, and the severity and priority level. Then if I hit explain, I'll see some extra explanation like this. And hopefully that's enough information for you to resolve the issue. This is a built-in check Lint report, but we also have all these same functionalities for custom checks, as you'll see later in the coding example. Now, are you ready for the magic for custom Lint rule? And we'll look at that specifically in the IDE editor session. So this is a Lint rule that I originally implemented for our app when we switched to Retrofit for network call. It forbids the use of leading slash in front of the endpoint. So you are able to preserve the full URLs. Now, this is in the process of open sourcing, and I will post it as soon as it's online, probably on my Twitter. So you're very welcome to add this simple yet very, very useful check if you're using Retrofit as well. As you see in the video, just like a built-in Lint check, you not only is the arrow highlighted, you'll also be able to apply a fix with one simple click, like this. Is it played? Okay, so here it highlights the problem and also show an error message. And then if I hit replace, you see that the leading slash is gone. So that's nice. And if you somehow miss this in the Android Studio editor, then Lint will still yell at you during build time in the Lint report we just saw the first slides. Well, Lint is a static code analysis tool. So what is a static code analysis tool? Very simple. Static code analysis tool is just an automatic static code review during the implementation phase. And it can be performed by various static code analysis tools, such as CATs. Well, say hi to my cat, Mika. Actually, maybe it's the time to reveal the secret that my cat is the one who actually reviewed my colleagues' PRs. So I have more time to do some fun stuff like Lint. And that worked out great. Well, go back to static code analysis. It helps to eliminate potential bugs and thus improve code quality. Although computer science itself has a very short history, static code analysis has been around since the 70s. Nowadays, more and more static code analysis tools are moving into the IDEs, which allows on-the-go checks. Android Lint is one of the most integrated, and it's just like a 24/7 lifeguard who's always there to help us to be closer to the perfect engineering approach. So Lint is Google's in-house solution, the static code analysis tool tailored for Android. It is built by Tor Norby from the Toolkit team. You have probably heard from him in the podcast Android Developer Backstage. He's one of the co-hosts with Chat House who did the opening for this conference and a lot of other conferences. And if you have not heard about this podcast, I strongly recommend this to every Android developer. Since Lint was built for Android, many checks have strong flavor of this operating system, such as missing permissions or too deep layout. I think the default maximum depth is 10, but you can also configure it using environment variables. I think 5 would probably be allowed already. And some other checks are use apply instead of commit for shared preference, or right to left compatibility enforcement, which is very useful if you're building an international app. A fun fact of where the name Lint came from. As I mentioned before, static code analysis dated back in the 70s, and the Lint tool for Unix V7 in 1979 is one of the pioneers. According to Tor, he named the Android Lint so to be an homage to the original, and also then people would understand what it is, a static checker. Lint was first introduced in ADT 16 in 2012 with around like 100 checks, and now it has nearly 300 checks already. Feel free to check out the official guide and the list of built-in checks there. So what are you waiting for? Integrate Lint with your Android Studio, with your Android project now. So what do you have to do for that? Well, as you might already know, you don't have to do anything, nothing. The built-in checks came with ADT, like I said, so you could just be sleepy like my cat when you're setting up the project and still get all the 200 plus checks for free. Wait a second though, does that mean that you're stuck with the right to check left forever? Well, even though you only want to build a simple English-only app. Well, then we'll have to talk about Lint configurations. You can configure Lint on different levels. You can do it globally, which is the entire project, or a specific project module, or like your production module, or text module, or even on the open files or the current files. And today I'll show two methods that I use the most and also recommend the most in practice. The first one applies to one single place in the code. Let's go back to the example of our retrofit lint rule. Instead of fixing it, I can also choose to suppress it. So it won't yell at me during the building time, but I still have all the other places in my code checked. And then, again, all I need to do here is a simple click. So let's look at the video. See? I have suppressed lint there, and it's on. So this is how you can disable it in a certain place. Next is my favorite, and it's probably the most powerful way, lint.xml. This is the snippet of the lint.xml for the Groupon app. It is on the root level of the project. As you can see, I can choose to ignore an issue by changing the severity level. I can also bump up the severity level, of course. And next, I can also choose to ignore some paths for an issue. This is particularly useful if you have an app that's been there for a while. I got this question a lot when people ask me, hey, I have this app that's been there for like 10 years, or, well, Android's only there for 10 years. But when Lint was introduced, I got like a thousand errors, and I have to disable Lint. Well, don't disable Lint. You can just use this technique to kind of create a baseline for your Lint checks. So then you can fix the issues on those passes later, but also kind of not allowing new errors on the same categories to be added. So, of course, custom Lint rules can be configured just the same way as the built-in ones. And now let's write one. Today, we're going to implement the Java constructor detector. The idea comes from the item 2 of effective Java. Consider a built-in pattern when faced with too many constructor parameters. By the way, effective Java is a great place to start if you're looking for some ideas on customizing Lint rules or just to become a better Java developer. So here are some assumptions that I have to make so that we can focus on how to work with Lint instead of, I don't know, handling the edge cases for all the kind of logics. We're assuming that there's only one constructor per object, so no need to check multiple constructors. However, note that the builder pattern is specifically useful for an object with multiple constructors which form a telescope pattern. So stay tuned as I'm also working on open sourcing the complete logics of this one as well. Next assumption, we only have optional fields so that we don't have the special build method for the mandatory field. And then all the parameters have the same naming as the corresponding fields, so we don't need to check which parameter got assigned to which field. And finally, we're assuming that constructor does field assignment only, so we don't have to worry about the body of the constructor. However, I think it's really straightforward to add the body, so you'll be able to do that very well after this talk. And now let's look at an example in the code. Look at the constructor of foo. It has 3 parameters. I was like, how dare you? Because we just said not too many parameters, right? And thus we want to say that this is not okay. We want to have something like this, a nice builder pattern. Pretty straightforward, right? So let's jump into Android Studio now and set up our project. Within a few clicks, we'll have the module for the library. Just click on File, New, and New Module. And make sure you choose Java Library and name it. And you should see the library within your project like this. Now we need to add the Lint API dependencies in the build.gradle for our module so we can use them in our code. This is the build.gradle. And it should have something there already now. We'll just add on top of it. So we need the Lint APIs and make sure to include the test dependencies as well. Before writing the Java code, let's take a closer look on the key components in customizing a Lint rule. So the most important part is the detector. It holds the logic on how to identify the issue, or issues, because one detector can actually detect one or multiple issues. A detector includes issues and scanner. An issue is a reference to the issue being reported by our detector. You see later in the code that it also set up the properties of an issue as well. And the scanner is the heavy lifting part of the detector, where it specifies the logic on how to detect the rule and also the fixes to suggest. After the detector is implemented, we need to put a reference of the issue into something called issue registry, which is which it stores the list of issues. It's kind of like Android manifest, where it registers all the activities, but instead we are storing the issues. Finally, I said don't forget tests. Lint has a great testing API, so we could make sure our rule is working before applying it to actual code. Now, this is our Java constructor detector. It needs to extend detector and implement the UAST scanner in it. And here I'm creating the issue. I need to name it and specify the ID first. ID is used in places like the Lint report and also the surplus Lint example we just saw. Next is the brief description. It's also used in the Lint report and also IDE's preference dialog, which is the label thing we saw early in the video. Then the full explanation. We saw this at the beginning when I was click on explain and it popped up a more comprehensive explanation. This can be multiple lines and you can also use a markdown markup such as bold, italic, or monospace. And then there's the category. There are many predefining categories such as performance, correctness, security, etc. I use correctness here, but you can also create your own. Next is the priority. This is the importance of the issue on the scale of 1 to 10. I use 6 here. As you see later, it matches the severity. So you know that the next one is the severity. And here I'm using a warning and it matches the 6 out of 1 to 10. And this describes the kind of the interaction with your building process and your build tools. I'm saying warning here so it does not fail the build, but remember for the retrofit one, I actually said that's fatal, so it's gonna fail the build. And last parameter in the issue is implementation. This is where the scope of the issue can happen. It can range from Java files or XML files or even Gradle files. Here, that multiple issue can reuse the same implementation. So it might be a good idea to create a class variable here if you are actually in that situation. So this is the issue. Now let's look at our scanner. To help better understanding the logistics behind Lint Scanner, I need to clarify 2 important concepts, AST and UAST. AST, or abstract syntax tree, is a tree representation of the abstract syntactic structure of source code for certain programming language. I know that's kind of twisted, but this doesn't really sound familiar for mobile developers, but they are actually rooted deeply in each compiling we do every day. This is basically how a compiler sees our code. And we're saying that in this tree, each tree node is a logic component, and we use the word abstract because it doesn't include all the details in the source code. For example, semicolons, braces, or parentheses are usually excluded. And here I have an example on how the AST looks for the expression b not equals to 0. So here you see that I have b, and that's the log. That's a comparator, and then we have 0. This is pretty straightforward, but this is only part of an AST tree. And what does the whole tree look like? So I want you to think, what does this tree represents? So we have while b not equals to 0. And then in the body of the while loop, we compares a and b. And if a is greater than b, we're assigning a equals to a minus b. Otherwise, we'll assign b equals to b minus a. And if we ever get out of the loop, I'm saying that return a. So it looks like a big tree, but it's really just a few lines of code like this. This is the famous Euclidean algorithm. It gives the largest common divisor and also a great example for AST. So feel free to look at it. Now it should be easy to understand UAST as we already learned what is AST. UAST, or Universal Abstract Syntax Tree, is a tree representation of the abstract syntactic structure of source code for several programming languages instead of one. This exists because some languages are similar in terms of syntactic structure. For example, the Euclidean one we just saw can represent both Java and C. And in our context, Kotlin is written by a group of magnificent Java developers, so it resembles Java in a lot of different ways. And thus, the UAST for Android Lint applies for both Kotlin and Java. Originally, Android uses the Lombok AST API to describe Java files, and then in 2.2 it switched over to PSI, and now UAST is added as to support Kotlin. The UAST library for Android Lint is developed by JetBrains. Some of the commonly used elements are UElement, which is the common interface for all UAST elements, and then UClass, UField, UMethod, and etc. So this is really straightforward, but remember that PSI API or Psi API, also from JetBrains, still coexist with UAST. And this is very helpful, as you see sooner in our scanner for some Java-specific functionalities. The elements are quite similar to UAST ones. We have PSI elements, which is also the common interface for all PSI projects, PSI class, PSI field, PSI method, and etc. I also have a link of the official APIs here for you to look at. And now go back to our constructor example. What does the tree or UAST looks like for this example? Note the mixed use of PSI and UAST. So we have an object that probably has some fields, and the constructor, and some methods probably. And we're only caring about the constructor in this case, which might have some parameter, and in real life, it probably have a body as well. Now let's go back to our Java constructor detector, and we need to override the get applicable UAST types and return UClass as we can, so that we can inspect its constructor. Also, we need to override the create UAST handler in UAST scanner. And for this handler, we need to override the visit class. There are also other visitor methods you can use, depends on what you are trying to detect. There are many, so we need to make sure that we're not calling super, as you see here that actually returns an error. But before UAST, when we were with PSI, we have to call super every time. So also note that here we're at the object level in terms of our UAST. Then Lint has many kind of really helpful methods built in already. So before you do things the hard way, try to look to see if there's some existing logics that you can borrow. For example, here I'm calling the really convenient get constructors method for UClass. Note that this returns an array of PSI methods. Also, in our abstract syntax tree, we have moved from the object level to the constructor level already. And next, we need to kind of get the constructor, and we want to iterate through them. Note that we're assuming that there's only one constructor, so we're actually only just getting the first one. Next thing, we are moving to the parameter list, and there's also a really convenient method called getParameterList from the constructor. So we are actually at the parameter level in the AST tree. So we're only actually going 3 levels down an AST in this example, but they can be quite deep in practice. So here I'm saying that we don't want any more than 2 parameters. And otherwise, I'll report to Lint with our issue ID, the scope which is the PSI element, and location, and also a brief description of the issue. Now we have the scanner already. We need to register our issue in the issue registry, as we said. Issue registry is really straightforward comparing to the detector. We extend the issue registry, create a constructor, and then we create the issue list and add our custom lint issue in it. In this case, we only have 1, but in practice, you might have multiple. And once we're done with that, we need to override get issues and return our list. Now, issue registry is done. We need to go back to our Gradle files because we need to pass this issue registry to the Lint, to our Lint registry so that it knows that there's some custom rules existing. Also, I'm construct a jar file, as that's really standard process. So I also need a task, copy lint jar, to put our custom rules in the Android Lint folder. And here is the command to do that. You can also add this jar to your app or publish to Maven or JCenter. I have put a link in the resources page on how to do that. And now let's test our new rule. As I said, Lint has a great API for testing. We just need to extend Lint detector test, and we want to override get detector and return the detector that we want to test. And we want to override the get issues, passing the too many parameters issue. And I also like to override the allow compilation errors and return true, because you see later that we need to actually create some test code. And in this way, I don't have to worry about having a perfect test code. So now let's test the simple case of no argument constructor. In this case, it's okay, so we should not expect any lint error. Like I said, we need to create some test code. So here I'm specifying the language as Java, and the code is actually just a list of strings. So here is the code. You can see that there's no parameter for the constructor. In this case, we're expecting no warnings. What I did is I just do lint.files and pass in the Java source code we just created. And I also do allow missing SDK to true for the same reason that we're overriding the allowing compilation errors. And then run, and I'm expecting no warnings. Then is the 3 parameters constructor case. In this case, you can see that there's three parameters in the constructor, and thus we're expecting some warnings, of course. Be very careful with the format of the warning message here, though, I think probably the best way is just to run it once and see the actual output. So this is the test for the detector. The test for the issue registry is just really straightforward, nothing different than a regular unit test, and you get it by taking a glance of the GitHub project that I'll post later. So now we have the detector, we have the issue registry, we have our test. We just need to run it. And you see, yeah, I'm success. Well, let's try it in some actual code. So this is a full object with 3 parameters in its constructor. Let's look at how it works. So you see that it actually throws the error message. Works great. Are we done? Well, like I said before, in Gradle 3.0, Lint actually introduces the fix for customized lint rule as well. Right now, it's limited to like replacing tags at the error location or replacing some attributes in XML. Fortunately, that works well for most cases, and so is our case. So I'll now show you how to suggest a builder pattern. Let's go back to our handler where we have the visit class method. Now it looks like this. But to add the fix, I need to construct the lint fix object. For this example, I'm saying that I just want to replace the text of the constructor with a helper method, with the code that generated by the helper method. And in this case, I'll say I don't want to reformat it and build. So you can see that the fix is actually using the builder pattern as well. So you should definitely do it. And also, don't forget, at the context of report, we need to provide the fix. At the end as a parameter. So here is the helper method that I'm using to generate the code. It's actually several helper methods. And you can see that I'm just using a string builder to build the lines of code that that I need for the builder. You see here that it's actually quite tedious work to generate a simple line of code, but I did this so that we can focus on using lint instead of like how to generate code. And fortunately, there's a great library called JavaPoint by Square that generates Java code conveniently, so you don't have to have like thousands of lines to generate, one line of Java code. So now we added the fix in the detector. No change needed in the issue registry, and we just need to change the tests accordingly. Let's go back to our no arc constructor test. Here, I'm saying I'm expecting no warnings, but at the same time, I'm also expecting no fixed diffs. It looks like this. We just need to append that at the end. Then for 3 parameters constructor case, we are definitely expect some kind of fixed diffs. So it's actually really long. It's probably like 5-6 times of the code that I'm actually showing on the screen. But it's, again, just some lines of code, and the easiest way is probably just to run it once and make sure that's the output you are expecting and use that in your test. So let's run it again. And of course, because I pre-recorded this, how does it work in the actual code though? So here I'm back in the full example, and you see that it actually allows me to just add like these many lines of code with one click. Isn't that nice? So are we done now? Well, I guess you know me already. I'm sorry, but there are just so much more you can do with Lint. Like I said, in the example of 2D layout, you can use the environment variable to configure Lint. And remember, currently in our example, I'm just hard-code the limit of parameters in constructor, like here. So why not use the environment variable if there is one? So within our detector, I will declare a parameters count limit and then try to assign it with the system.getIf Android Lint constructor parameters count limit if there's a valid one. By the way, that's really bad naming. You should use someone better if you've got one. And all I'm doing here is I'm doing some sanity check. I'm seeing if there's a valid value with the environment variable. If not, I'll just use my hard-coded tool here. And then don't forget to change it back in the visit.class. So see here, I'm using the parameters count limit instead of the hard-coded one that I was using before. The changes in the tests are trivial. So just use the setIf to mock the environment variable. So again, check out GitHub. Very simple changes, but this just brings your custom check to another level of solidness and user-friendliness. And that's the end of the coding session. So now we've got a comprehensive understanding of Lint. Let's chill down a little bit with my cat. She likes to sniff the flowers from time to time when she's taking a break. And take a look at some of the common static code analysis tools for Android. We'll go over some third-party tools, checkstyle, PMD, Findbugs, and then we'll do a comparison of to decide when to use which. By the way, those are the ones that we're actually using in the production app, and I strongly recommend you to use them as well. Most of them can be just set up by one line in the Gradle. So let's go into it. First, we have the checkstyle. Well, coding standard is always the first thing we need to learn when we're starting with a new language. As the name suggests, checkstyle, developed in 2001, takes the tedious yet essential work of enforcing Java coding standard off the developer's shoulder so we can focus on more creative stuff. It has checks like indentations, white spaces, placement of brackets and parentheses, and etc. Note that checkstyle is highly configurable, and feel free to take a look at the official document and the example of Google Java style guide in case you're interested. The second one is PMD, came around in 2002. Funny fact of this tool, there's not an official name for PMD. Some of the interesting name propositions are pretty much done, project meet deadline, and the one that sounds the most legit is programming mistake detector. Instead of enforcing coding standard, it scans through the file code, the source code, looking for common programming flaws such as empty track catch and using equals instead of equals, or unused variables and imports. And this is really important. PMD is quite powerful as it actually is a multiple language tool. It supports 8 languages, including Java, JavaScript, and XML, etc. So you know why we're using it for Android, because we use both Java and XML, right? Last but not least is Findbugs. Findbug is a Java static code analysis tool built in 2006. The idea is similar to PMD as the name suggested, but the actual mechanism is scanning through the bytecode instead of source code. Here are some problems that Findbugs found and PMD doesn't, such as improper use of equals, which is like you use equal method fails on subtypes, or impossible cast, a collection which contains itself, or infinite loops, etc. And also here's the official document. So let's go into the comparison. First, we have checkstyle, which, so this is in terms of Android development. It's working on the language of Java and is highly configurable. We use it for Java standard enforcement. And then the PMD is for Java and XML, again, in terms of Android development. And then it's really highly configurable. It does source code error check. Last is Findbugs, and it's also working on Java only. Configurability is pretty good. And we use it for bytecode error check. The last is Lint, which we've been talking for the past 40 minutes, so what do we use that for? Well, Lint is working on a lot of languages such as Java, XML, GUI, or Gradle, and also Kotlin. This is the only one that has the Kotlin error checks now. And it's highly configurable and customizable. And what do we use that for? So I would say that it's good for both style and error check, specifically for Android related, such as the Android Java or XML, and also Gradle, Kotlin, and some business logics. Say if at Groupon we have thousands of deals, right? For each deal, we want to say the description of this deal can only be within 1,000 characters limit. Then we can use Lint for that. And another great use is library tests. I talked to Jake before this conference, and he said that he actually provided the lint checks for his users within the butter knife so that the library users could get your checks for free. For example, the retrofit one would be a great example as well if the retrofit team actually decide to include it within their project. And I have reasons to believe that in the future, Lint is going to perform a more and more important role in Android development because of the seamless integration with Android Studio and continuous support from Google. So, get started with it, and that is the end of our talk. Here is the link of the GitHub project, and again, the ways you can reach out to me if you have questions. I'll let you guys take a picture. So I have one more cat picture in case you're not too bored. So yeah, my cat is ready to test water. How about you? And before Q&A, Groupon is hiring, and we always open our doors to great engineers. If you're interested, reach me out at any time for more details. And questions. By the way, if you have questions, could you line up in the mic there so everyone else can hear it? No questions. Okay.
What kind of rules do you have to decide when it makes sense to create a lint rule? And because I mean, you can think about a lot of things that are wrong that you can write a link tool for it, but how do you decide which ones make sense and which ones doesn't?
Yeah, so that's a great question. Actually, I would say this would be similar to when you decide to use a library. You have to weigh the cost and benefits of using that library or implement the lint rule. So if you think that the time and effort you put in implementing this lint rule is going to save you more time in actual kind of work, then I would say go ahead. Otherwise, if you think that's something that's not going to repeat a lot, I would say just don't waste your time unless you want to practice your skills on writing lint. Does that answer your question? Okay, next.
You said that lint comes automatically built into Studio. Is it automatically running without pulling in the dependencies that you showed us? And like the report you showed at the beginning, is that available out of the box?
Mm-hmm. Yeah, so it's automatically turned on. You can turn it off though, although I'll say don't turn it off. If you want to disable for something, you just use the lint.xml or suppress lint, but it's actually automatically running every time you compile.
So where do we find the report?
If you have an arrow, it's going to pop up. Or you can also, I think there in the IDE, you have something called inspect code. And if you click on that, that's going to kind of run the command line basically of Gradle lint certain project. And then you'll be able to see the report there.
Thank you.
Does that answer your question? Tricky.
Hi. It's too high. I have a question about the UAST. So you were going through the different nodes and the elements. Is there a tool that you can actually see the whole tree so that I know which node to look at? So if it can I give it some Java code and then it will spit out the tree so I know which node I should be checking for the lint?
That's a great question. I would think it's a good feature for Tor to add. But if you're trying to get familiar with AST and UAST, I think PMD actually has kind of a tutorial session of the tree in their official documentation. I can send you the link at the end of the session. And I'm afraid that there's nothing like that available for Lint right now.
Okay, thank you.
Thanks.
So suppose we have like thousands of warnings at the moment in the repo. and my team don't have enough time to solve it. Is there any way to just have Lint report new warnings?
Yeah, there's actually a way of doing that. You can see it in the Lint configuration page. I can send you the link at the end of the session. But you can also use the Lint.xml thing, which I showed earlier, to do that. And like I said before, don't turn it off. Don't just turn it off completely. And any more questions? That's it. And we're right on time. Thank you, everyone, for coming, and enjoy the rest of the conference.